Welcome to solverfy.
Okay, in this problem, we're asked to look at the Balmer, at a line in the Balmer series, specifically that for the gamma line in hydrogen. And for that particular line, we're asked to find the wavelength, frequency, and energy of the photon corresponding to this line. So recall the equation for the Balmer series, which gives us the wavelength in terms of this R value and a index for a lower and upper level. R is 1.097 e to the negative 7 inverse meters. So recall for the H gamma line, the lower value is n equals 2. The upper value is n equals 5. And the text discusses the convention for how these are determined. The upper level increases with the Greek letters, so H alpha would be 3, beta is 4, gamma is 5. That's how we get to these particular indices. So with that said, we can jump in, plug these values in, and find this lambda. So as I mentioned, just plug some numbers in. So for the lower, we have 1 over the lower, 2 squared, minus 1 over the upper, 5 squared. All this is inversed. And after plugging these numbers in, plugging our value for R, computing, we are left with a value of 434 nanometers. Okay. We can relate this wavelength to a frequency and an energy for a photon using the expression E equals HF, also equal to HC over lambda. Which tells us that F is equal to C over lambda, and E is HC over lambda. Thus, we can find E to be a value, let's compute it, using the speed of light and our given lambda, 434 e to the negative 9. Okay, frequency first. We have a frequency of 6.91 times 10 to the 14 hertz. We have an energy of, using Planck's constant, and the frequency we just found, a very small energy, 4.57 e to the negative 19. These are in joules. So we can divide by 1.6 e to the negative 19 to convert to EVs, which is probably more appropriate anyway. Okay, and we are left with 2.86 electron volts, which seems reasonable. Okay, so these are our results. We had to calculate a couple of these on the fly. And that's it. That's all we're asked for. Thank you very much.